128. 1 minus sine over 1 plus sine equals secant theta minus tangent theta squared. Where do you want to start? Owen, which side should I do? It's a toss-up, really, but...
Maybe the left side. I'm not really sure.
Left side? Let's try it. Let's see if we run into a roadblock. 1 minus sine theta over 1 plus sine theta. Everybody take this one out. Write it. If you didn't get this one, do this with me. What could you do to make life better? This does not look obvious at all. Yesterday we talked about x plus y times x minus y. What was that equal to? Remember your algebra? Gabby, do you remember? Well, it'll be xy minus xy, which cancels out and gives me minus y squared. This is called the conjugate pair. Conjugate. It helps us to be able to lose the middle term. So I'm going to use that idea right here. I'm going to multiply the top and bottom by the conjugate of this one. I don't want this in the denominator, because do you see anything in the denominator here? I don't. So we're going to put in place of that 1 minus sine theta. 1 minus sine theta. Kind of a weird move. Is that like multiplying by 1? Legal? Jacob, legal? Multiplying by 1? Yeah, can do that anytime we want. So in the top, I'm going to get 1 minus sine theta times 1. Negative sine theta times 1 is negative 2 sine theta. And then we're going to multiply the back 2. Negative times negative, it's a positive sine squared theta. In the bottom, I'm going to get 1 times 1. The sine theta minus sine theta cancels out, and you're going to get minus sine squared theta. Turn to your neighbor. Tell them what we just did. Any clue on what to do next? We're in deep. Avery, what's that? Before, oh, what would you cancel? No, can't because of these plus and minus signs. Don't cancel the ones because that's an illegal math move. Can't do that. Anybody see what we could? Yeah. Yes, this one right here, and it looks like a long shot, doesn't it? 1 minus sine squared. But remember that cosine squared plus sine squared equals what? 1. So let's move this to the other side. So I have cosine squared equals 1 minus sine squared. Ah. So I can replace the blue with what? Yeah. Now you're thinking, yeah, that helped. Thanks a lot, Dr. Sauer. That did nothing, right? But I'm going to just kind of keep you moving in this direction. What if we had 2 plus 8 plus 16 all over 2? How could you rewrite this? That might be helpful. Obviously, you could just add them up. But is this the same as 2 over 2 plus 8 over 2 plus 16 over 2? Is that the same thing? That is exactly what I'm going to do next. I'm going to take each of these, and I'm going to go 1 over cosine squared minus 2 sine theta over cosine squared plus sine squared over cosine squared. Again, that looks real helpful, doesn't it? Yeah, let's do that. I like it. What is 1 over cosine squared the same as? What's 1 over cosine? Secant. Good. What is, well, and I'm going to have a 2. What is sine over cosine? Tangent. And what is 1 over cosine? Because 2 sine theta is the same over cosine squared, could be thought of like this. 2 times sine over cosine times, what's 1 over cosine? We just said it before. Secant theta. And what's sine squared over cosine squared? What's that? Tangent squared. Okay. Make my day. Does this factor? Walker, what do you think? No? What do you think, Nathan? Does this factor? Remember, this is squared. This one's squared. Yeah, I think it does. Secant theta. And this is going to be tan theta. And what if we put a minus in both of those? Will that middle term work? Oh, cool. So this is the same as secant theta minus tangent theta to the what power? Squared. And that's what we wanted. That just happened. Not amazing? All of this was because we had a couple of tricky things. The first tricky thing was conjugate. The next tricky thing that we had was the Pythagorean identity. And then all of the rest is pretty much algebra. I think the rest follows pretty well. You might have a little issue with the factoring, but nice work. What do you think, Masha? Which is the hardest part of those three arrows? Yeah. Well, and right, and you're just going to try things until it works. Any other ones? I'll do one more, either 115 or 91. Which one would you like to see? Would you like to pick, Jasper? You want to pick? No preference? How about, yeah, 115. Let's try that one. Okay. By the way, I think it was Charlie that picked that side. Was it Charlie that picked the right-hand side, or was it Owen that picked that side? You picked the correct side. Then doing the other way would have been tough. If we do 115, I'm just going to kind of show these quick here so we can move on. What I did with these two is I got a common denominator. So whenever you're doing fractions, you want to get a common denominator. 1/2 plus 1/3. You're going to have to multiply by 2 over 2 and 3 over 3. And then you could add those up. Well, I did the same thing here. To get a common denominator of cosecant theta plus 1, cosecant theta minus 1, I multiplied top and bottom by the conjugate. Cosecant theta minus 1, cosecant theta plus 1. Is that part all right, Gabby? Then what I did is I multiplied them out. And so now I have a common denominator. And I have this in the top because this times 1 and this times 1. And then I just gave them the same denominator. Ooh, I went kind of quick there. Let's do this a little in step here. cosecant theta minus 1 plus cosecant theta plus 1 over cosecant squared theta minus 1. Now this is a Pythagorean identity. What's cosecant squared minus 1? Equal to, well, let's write it here. 1 plus cotangent squared equals cosecant squared. Okay, so what is cosecant squared minus 1 equal to? There you go. So I'm going to make this equal to cotangent squared, and these will cancel out, and I'll get 2 cosecant theta. I'm going to let you finish this. You're going to use your change to sine and cosines. You'll get that. You'll be fine. But I'll let you finish that.